Hi, thanks for coming tonight. My name is Sam Andrew, and my presentation is titled Predicting Poker Hand Outcomes. A quick aside about me, I love skiing and hiking. I grew up with Italian Spinonis and hope to own one myself someday. I started playing poker as a kid, and my love for the game has only grown. I'm always looking for ways to improve. Using a database of poker hands I acquired over the last year and a half, I hope to develop a model that would guide my decision-making process in whether or not to play a hand. Poker is a game of high variance, so my hope is to build a model that will outperform random guessing. Using string data from a SQL database that stores my online poker hands, I created a number of features to inform my model. I created over 50, but I elected to use just 10 of these for my modeling. Just to highlight a few of these, the big blind is the amount of chips one player has to put in at the start of each hand, and as a tournament progresses, it increases in size. Big blinds and stack is simply the amount of chips you have divided by the size of the big blind. It is used to describe the relative size of a stack. As you can see from the plot, most of my hands occur when this metric is lower, and as it increases, my win rate goes down. The number of players yet to act and not fold are the number of players who have entered the hand when I make my first action. I tend to win more when fewer players have entered the pot, which makes sense because I'm competing against fewer opponents. To capture the strength of my cards, I use something called the Chen formula, a mathematical method for ranking Hold'em starting cards created by Dr. Bill Chen. As card strength increases, so does the rate at which I win hands. Most of my hands occur in the 4 to 10 range. For the purposes of my modeling, a raise is when somebody bets more than the minimum amount, and a re-raise is when somebody repeats that process. I win the most when there have been no raises, and I tend to lose slightly more than I win when there's already been a raise. The outcome is my target variable. There are two classes. The positive class encompasses cases where I made money or broke even, while the negative class represents cases where I lost money. These two classes are relatively balanced. In order to predict hand outcomes, I used a gradient boost modeling method. Precision, which measures what percent of positive predictions are truly positive, was the metric that I was the most interested in. In tournament poker, it is generally preferable to not lose money as opposed to make money. So high precision ensures I'm not predicting too many hands as positive that I very well may lose. I grouped the model's predictions into 3 different categories. On the left, a prediction of play it suggests that I will win a high proportion of the time. Considering only hands in this category as positive yields a precision score of 0.74. A prediction of caution means I am likely to lose about half of the time. Although riskier, I will have to play some of these hands in order to maintain a well-rounded strategy. Counting everything in this category as well as the play it category as positive produces a precision score of 0.65. And don't do it on the right represents where my model predicts I will likely lose. To utilize my model, I developed a Flask app that allows me to get fast predictions. In some cases, the user inputs the feature's value explicitly. Other features are calculated under the hood. For example, the user will input their stack size and the size of the big blind, and the app does the division for them to get big blinds and stack. The output page shows the model's prediction, as well as the information used to make it. I further developed my Flask app to allow for A/B testing, which saves the information used to compute a prediction, whether the model's prediction was shown to the user, as well as the hand's outcome to a CSV file. I hope to use my model to inform my decision-making process in situations in which I feel that the expected value of playing a hand is close to the expected value of not playing a hand. In data science terms, I'm the model making the final prediction, but that prediction will be informed by the gradient boost model that I developed. Going forward, I hope to incorporate statistical features, which are something I developed but lacked enough usable data on to include in my modeling. I would also like to further develop my Flask app to allow other players to upload their data and get predictions specific to their own playing style. Any questions?